So, just taking a really quick little video of this new unit that I was talking about. So this here I've got all of the cables connected up to the oscilloscope to do some testing very shortly. But this is what you can see as the system main relay. So the battery, system main relay, here we've got the service disconnect. This is the inverter, so you can see two high voltage coming in to DC, positive and negative, and then we've got the three phases coming out. So DC side is here, AC side is here. I'll get the motor going shortly, but just as an idea, we've got induction rotors here like that, or you can switch that out just like that for a permanent magnet. So many experiments that you can do with this system, but one that I'll just show you right now is going to be this here. So I'll try and do this. We've got a start button, so obviously we've got a brake because it's a hybrid or electric vehicle. Put foot on the brake, touch the start button, and you can see here now is the system main relay is operating. And what you can't see there is just the on off, but there's now the three relays have been switching on and off, and when we switch off you can see the start of passive discharge. So the passive there is a slow, and then the active discharge goes down quickly. And some of the relays that have been kept on a little bit longer just to show, or as part of the testing, to see if any of the contactors were welded closed. So just to see that again from this side, so brake, you can see the visualization of the relays being switched on and off, and then going into ready mode. Second thing that I've got going here is inverter control. So you can see here, this is you can either, I've got it set to auto, but you can also do this to manual. But just to see the IGBTs being activated very slowly, just to cause the rotor to spin around. You can see that. I can literally take it out while it's still going, switch that out, and you can see effectively the rotating magnetic field. So that's just at the base level there. Now the next version here is to control the frequency converter, so I can adjust that again. So now we're actually driving it like a proper electric motor. Again, it's not really intended for touchscreen use, much easier on the computer, and these experiments are guided. It's not for the students just to experiment with. But you can see there that the rotor is now interacting with the magnetic field within the stator. And again, the beauty of an asynchronous or induction motor is I can stop it and it will take off. If I put in a permanent magnet, you can see it takes some time for it to find and align or synchronize with that rotating magnetic field, because this is of course called another name for the permanent magnet rotor is the synchronous rotor. Asynchronous, synchronous. So now just a little short thing just to show what happens here with the system. So this is like the interlock, this is like the service disconnect. If I disconnect that, it's opened up the interlock and the system has now shut down. So it's discharged the capacitors and opened up the contactors, so there's now no high voltage. You can see here the inverter is still running, trying to run, but there's no voltage coming in. Of course, on a real vehicle, the inverter would stop as well, but that's just to show what happens with an interlock like this. Okay, next experiment that I've got here is with the oscilloscope measuring across two phases. So the current always runs through two phases of the stator, and what I'm doing is measuring across one of the phases, so across one of these resistors here, to get an indication of voltage drop, which of course is an indication of current flow. So looking at the oscilloscope right now, obviously I've done it pretty quickly. Normally I would use a shunt here, that's why I'm getting all of the peaks on the signal. But if I just stop that for a second, you can see this is the digital signal that's being produced by the inverter. So that's these LEDs, you can't see them in this light, but they're flashing. And that frequency is around about, so the frequency of the pulsing is around 8,000 hertz, which is what you see in a real vehicle. And that's creating, so that's the digital signal, digital DC signal. And what you're seeing here is when I'm going across the resistor on one phase, so the blue signal is across two phases, this one is across the resistor in one phase. That's the representation of the current flowing through one of the other phases. It's not the same phase, you can see there's a phase shift there, but you do see a phase shift in the current to the drive signal as it is anyway. But yeah, just one of the dozens and dozens of experiments that you can do on the system. So, and again, doing this on an electric vehicle is not only difficult, it's actually very dangerous.